I'll start by just saying how excited I am to be here today. Thank you with all of you folks. As Chase said, it's so exciting to see folks so interested in fire as fire ecology, fire practitioners, wondering about fire. So welcome all of you, and thank you, that wonderful welcome. As Chase mentioned, I'm director of, basically that means I do restoration, but fire ecology is by far the most powerful tool that we have to restore our natural areas. So I'm very excited to be here talking about that today. So a quick map of Maryland. The Nature Conservancy has about 30 preserves in the state. Those with the red flames are where we've been burning, and those with orange are ones that we're hoping to burn starting this spring. We burn about 1,000 acres or so a year on Nature Conservancy preserves, and an additional 1,000 to 3,000 acres of assists. So with our state partners, with our federal partners. So a little bit about what we're talking about today. So our fire-adapted communities on the Delmarva Peninsula are pretty diverse. We have oak hickory woodlands, mixed pine hardwood forests, pine woodlands, savannas, inland dunes, and Delmarva bays and other open emergent wetlands and grasslands. So a whole suite of really interesting disturbance-driven systems which require fire in order to flourish and to persist. The Nature Conservancy, we're primarily burning for ecological reasons. We're working to promote species diversity and protect our rare, threatened, and endangered species, improve wildlife habitat, restore and maintain these fire-adapted communities we talked about, promoting open forest structure and reducing competition from non-desirable species, and to promote forest health and resiliency. But we're also burning to protect the communities around us through hazard fuel reduction. So what do we know about fire and fire history? We know that when early European settlers arrived, they saw lots and lots of examples of indigenous people using fire. Captain John Smith, when he first arrived on the Eastern Shore, he was a meticulous note taker, and he has lots of fascinating journal entries documenting native people, in this case the Accomacs, using fire to hunt, in this case surrounding fire very successfully in order to have a more successful hunt. But indigenous people had a tremendous amount of knowledge of fire and lots of different ways to use fire. And we feel that it is really the fires that they were setting that have shaped the character of the vegetation here on the Delmarva and throughout the mid-Atlantic. Other reasons was for crop management, improving fruit production, to fireproof areas. They too understood the value of prescribed fire to help their communities. Pest management, I'll talk a little bit about that, and clearing areas for travel. And one of the things that we're trying to do at the Nature Conservancy is to put that tool back in our indigenous communities' hands. One of the things we have is through the Indigenous Peoples Burn-In Network, where we're enabling the historic fire practitioners, the indigenous people who are still here, training them, giving the equipment they need, and working with them to bring fire back to their land. So this is an example on Taylor's Island, where we were able to work with an Assawawash tribe and work with them on a burn plan that encompassed their ancestral lands, as well as state land, as well as Blackwater Fish and Wildlife Refuge. And together we were able to accomplish this burn, and they were able to participate in the burn, which was a really satisfying moment. And here on the bottom, you can see them after the fire, they're setting their muskrat traps. And there was actually a really good article about this burn. This burn was last in spring of 2022. So in Yale Environment 360, they did a nice write-up. So what happened? Why are we here today? Why are we talking about bringing fire back to the landscape? So let's start a little bit by talking about fire ecology. Can you see my mouse if I move it? No, okay. So we know that throughout history, if you look at this graph way up here, we've had there's always been periods of drought and wet periods. So there have been years of high fire frequency and low. That's always been the case. And we can go back to the 1500s and we know that periodicity has occurred. But then we had a series of really catastrophic fires, wildfires in North America. And in the early 1900s, the Forest Service was established, and one of their missions was to stop forest fires. Although it really wasn't until after the World Wars that mechanization improved sufficiently so that they could really effectively put those fires out. In 1935, there was an act called, well, I call it the 10 a.m. Act or policy that said all wildfires recorded had to be put out by 10 a.m. the following morning. And so with but it happens. So with acts policies such as that, we saw this really dramatic drop in wildfire activity in the 40s, and that's really gotten us to where we are today. So what does that mean? What has happened? So let's take a walk through the forest. If I take a walk through the woods in my backyard, this is what I grew up expecting. You know, it's kind of dark. We've got lots and lots of trees. They're kind of small. They're pretty close together, but that's what I have learned to see. Not a lot of herbaceous diversity, not a lot of shrubs or grasses or forbs underneath. But maybe this is what we should be seeing. When we read accounts from early settlers, they described forests that were open, fewer bigger trees, more spread out with a tremendous amount of diversity between the trees and the understory and the herbaceous layer. Those early settler accounts describe forests that were so open that you could drive your horse-drawn carriage through them. So maybe this is what we should be working towards. But what happened? How did we get from this to this? And how do we get back? Well, obviously, I'm going to talk about fire. But there's so much that we need to understand about fire, how much, how hot, how frequently. So let's go back again, now even further. One of the things that we can do is we can look at pollen records to get a sense for how much fire was occurring at what we're calling our prehistory. So with pollen cores, we can go back 12,000 years. And this is a pollen core that Grace Brush took in the early 2000s. This is Anacostia, but it's pretty, I think, representative of the Delmarva. So if you look all the way on the left, you can see where, where it says centimeters. Up here. So if you go back 18 centimeters, that's about 400 years ago, and that's about when Europeans arrived we'll call it on the Eastern Shore. Now, if you go all the way to the right side of the graph, you can see charcoal. And so here again, about 18 centimeters down, that's when European settlers arrived. And you can see there were a few post-logging area big wildfire events. But way back before that, there's a tremendous amount of carbon being laid out, carbon in the atmosphere, smoke, and charcoal being laid down in the sediment layer. So this shows that there was a tremendous amount of fire activity occurring on the landscape before we arrived. Another way that you can get a sense for how much fire was occurring historically is you can look at fire-adapted trees because they don't move very fast. So this map is ranges of fire-adapted trees that we have here in the east. So in red at the bottom, we've got longleaf pine, and that's pretty much the most fire-adapted tree that we've got. And it almost reached into the Chesapeake Bay about 400 years ago before settlers started pushing it back. So we know pretty darn close to us we had it. But then you could look at shortleaf pine. Shortleaf pine is on the Delmarva and all the way south. That's a very fire-adapted tree. Up north, we've got pitch pine, and then in the Appalachians, we've got table mountain pine. So these are all fire-adapted pines. So this is telling you that historically, there must have been a tremendous amount of fire in these areas for these trees to be here. I'm going to draw your attention to pond pine right here, smack, pretty much taking up the whole Delmarva. Pond pine has a really interesting adaptation, which is serotiny. So pond pine is Pinus serotina. And serotiny is when a pine cone is glued shut with resin and it needs a trigger such as a heat source, say from a fire, in order to open up and release its seeds. And it's a fantastic adaptation because it's releasing those seeds at the perfect time. It's right after all of the competing vegetation has been burned off. The ground is nice and dark, so it's going to absorb a lot of radiant energy. You've got all this nitrogen that was just released. So this adaptation really gives these fire-adapted species an edge if they're able to release the seeds right after a fire. So let's take this a little bit further. And look at trees kind of on a continuum of fire adaptedness. So way on the left, you've got your serotinous trees, such as we talked about pond pine. Here I've got table mountain pine. So these trees really need fire in order to persist, in order to be able to successfully continue to regenerate. But then you've got fire adapted trees or fire facilitator trees. And these trees do really well with fire. They've got adaptations. And this is some oaks and yellow pines now. They've got really thick, chunky bark, so they're physically insulated from fires. And they're also able to heal over their wounds very effectively. They also have characteristics that actually promote fire. So when oak leaves fall from a tree and dry up, they curl up and they land on top of each other in this fluffy layer of leaves. And so when a wildfire comes through the area, those dry, crunchy, air-filled leaves are going to pull that fire across the landscape and continue the fire down. Similarly, with the yellow pines, the needles are very resinous. Also, these fire-adapted trees tend to have very long taproots. They're very drought tolerant. Then you've got fire-resistant trees like the white pines. These trees can survive in areas with longer fire-free intervals. So if you don't have fire, say, but every 10 or 15 years, the white pines can become established. And once they're big, they can easily withstand a wildfire once they're a little bit more mature. And finally, you've got the intolerant or fire impeder trees like red maples or black gums. They have really, really thin bark. So now if a tree comes through an area, chances are a fire comes through an area, it's going to kill that tree. But additionally, these leaves, when they fall, they're very, very flat. So if there's just the littlest bit of moisture there, those leaves are going to hold that moisture in. And over time, these trees are going to create wet mats around themselves. So now if a fire moves through the area, chances are it's going to go out as it reaches these trees. So what's happening is these trees are making the whole area more wet or mesic. And the term here is mesification of our forests. As we've taken fire out of the system, we're losing the fire-dependent trees. And the fire-adapted trees are becoming outcompeted by these thin-barked trees that are able to grow more rapidly now without fire. But what's going to happen is over time, we know with climate change, we're going to have longer periods of more extended drought. So if more of the trees in our forest are these wet or mesic trees, when we hit these droughts, the entire forest is going to be more stressed and more susceptible to disease outbreaks and pest outbreaks, as opposed to if we are able to continue pushing fire through these forests, we'll end up with more of the fire-adapted trees, and they'll be more drought tolerant, and the entire forest will be more resistant to climate change. Just to bring this back a little bit to the Delmarva Peninsula, there was actually a study in 2000 by Kerwin and Shugart looking at almost exactly this, looking at the correlation between thin-barked maples and beech trees. And they found that where you had maples and beech, you tended to have far less charcoal in the soils of those areas. So bringing it right home to the Delmarva. All right, so why do we really care about this? So we know we've got our tree communities that we want to keep, but there's also so many other levels that are impacted by fire. For example, sundial lupin loves fire, loves disturbance, likes open areas. And we know that if we're opening areas and burning, we're going to get more lupins. But the frosted elfin butterfly, which is on the verge of being listed on the endangered species list, is a host of, it requires a sundial lupin. So by bringing fire back, we're cascading the good by assisting other species that depend on the fire. Not all insects like fire. Ticks don't. Ticks really, they like those dark, shady, damp forests I was telling you about earlier. If you open up an area, ticks desiccate very, very quickly. They don't like air circulation. They don't like a lot of light. And we know that ticks have been spreading across the US, and with them is spreading the diseases such as Lyme's disease that they transmit. And in a study by Elizabeth Gleim, she found that in areas that are burned frequently and in large blocks, there can be as much as a 98% reduction in ticks and in the virulence of those ticks in areas. And Native Americans used to use fire for pest management, so they already understood that. So that's just another reason now we're kind of connecting fires to human health here. So I talked a little bit about our different community types, and I want to talk about a really cool wetland. These are Delmarva bays, and these are these seasonally filled wetlands that we have. In the summer, they're dry and almost prairie-like, and in the winter, they fill with water, and they're essentially ponds. But we believe these are fire-adapted systems, and you need fires to periodically run through these areas in order to keep them open. And I'm showing this just to show how incredibly fire-adapted these plants are. Here is the site in March before our burn. Here's on burn day in April. So here's what it looks like immediately after the burn. And by June, you have this amazing resurgence of this vegetation that's coming in. So when you see this, to me, that really says that these communities have evolved with fire. I'm going to show you a different Delmarva Bay. This one is up in Queen Anne's County. And this one has a federally listed species, Canby's dropwort, a plant. Maryland, it only occurs in one site in Maryland for our whole region. And when we first started managing the site, in '92, we only had 2 plants. And here, this pond, even though it's a Delmarva Bay, it was basically a wet woods. It had grown up in trees. So we spent, starting in 2001, many, many years just cutting back trees, and making the pond more open again. And that was very successful. We brought the population up into the 200s. But we felt that what we really needed here was fire. But we were very hesitant to put in a fire line because this is such a sensitive habitat that we didn't want to negatively impact the site. So we were able to write a burn plan that said that, so the pond, the open pond, has these fine fuels, these grasses that dry very quickly and burn very readily, whereas the woods around it are dark and shady. So the burn plan said that if a test fire in the woods goes out, say we burn just a couple of days after rain, then it's okay to move forward and burn in the pond, in the bay, because we know that the fire is not going to carry into the woods. And as you can see, the results were fantastic. The population just absolutely skyrocketed. We've actually had 3 burns since. And I'm going to show you a really quick video just to show you how that works. So let's see if it chooses to play. So it's sped up. So it's a little jumpy, as if you can't tell. So this is me in the foreground, and there's Gabe in the middle directing. So I'm doing this line of fire, and there's one other person on the far side burning. And you can see right here the shade from the woods around. And it's doing just what we had hoped. Just as it hits that shady line, it's going out. And now we've got one more person going down the middle with fire. So just with 3 lines of ignition, we were able to burn off this entire pond with virtually no holding. And what's amazing is that the pond was still damp. The sphagnum was holding water. But the way that the grass is just pulled across this wetland just really shows how fire adapted these plants really are, these communities. One guy even comes and tries to put just a little more fire, because I could tell you, it's near Henderson, kind of. So, all right. The burn itself was pretty fast. It was 45 minutes, more or less. I think I got it down to a minute. A lot more planning than 45 minutes, though. All right, so we know that fire is great, right? But it's really hard. You have to write a burn plan, get all your permits, you have to put in those fire lines, you have to get all your equipment, you have to get your crew. So a lot of people say, well, why can't you just log instead if what you really need is just getting more light to the ground? So yeah, you can use logging as a fire surrogate. So we have an example here on our Nassawanga Creek Preserve where we had a really nice wetland that had a loblolly pine plantation on it. And we had a drought year, so we were able to go into that wetland and pull out those lobs. And the results were great. We found 7 white-fringed orchids that we hadn't documented here on the site, and a handful of these yellow-crested orchids. So just by taking the loblolly pines out, we had some great success. But then we burned, and whoo, Nelly, it was better. So we had over 50 of the white-fringed orchids, 20 of the yellow-crested, and 3 of these Canby's bog orchids, which are a hybrid of the other 2. And what's really cool is This orchid hadn't been seen in Maryland in 18 years. And when we looked back at the records, we saw that 18 years previously, there had been a wildfire on that same spot. There's a wildfire and that orchid's there. And then, after the wildfire, they planted the lollies and it was gone. And then we take the lobs out, we burn, and it comes right back. So it's crazy to think about how these species are hunkering down and they're just kind of waiting for that fire. Logging doesn't always work as a surrogate. I have an example here of the eastern pine barrens tiger beetle. It's fire adapted. It likes this really fine sugar sand, and it needs a lot of bare ground, a lot of exposed sand in order to hunt and to thermoregulate. And we had a population on this stretch of road. You can see the nice white sand with really dark loblolly pine plantations on either side. And the beetles were only on the road. And we were really nervous about that because, a couple drives up and down at the wrong time and you're decimating the population. So we did a really, really careful timber harvest. We did it in the middle of winter. You can see there's snow on the ground. We didn't put any equipment up on that road. And the results were terrible. The population absolutely tanked. So in this case, just logging did not do the trick. But then we were able to come in and burn. And this is one of the sites that we had clear cut. And you can see after the burn comes through how nice and sandy it is underneath. And after that, a few years later, the population came back really nicely. So I don't have numbers for you, but you can kind of see these are the areas that we had opened up, how it just got really nice and open, lots of bare ground, lots of sandy soil exposed. So not only did the beetle get off the road, increase in population, but it was actually getting off the road, which was exactly what we wanted. How am I on time? Oh, crap. Okay. No. You'll get all this. Sorry. All right, last slide. What about carbon emissions? A lot of times people are like, oh, well, burning is bad because you're releasing all this carbon into the atmosphere. Well, the answer is it depends. So on the left, you've got a control burn, and it is a control burn. We literally write a prescription for this. It says it can't be too windy, not too hot, not too dry. We put in a fire line so that the burn is right where we want it. And yes, trees die, but other trees that survive are going to grow bigger, faster. What you're not seeing is underneath those trees and the herbaceous vegetation, which is going to come back like crazy. They're putting so much more roots into the ground now, locking in all that carbon. That incredible green up is a tremendous amount of carbon being locked in. And the stuff that doesn't completely burn, all that charcoal, that's going to work its way into that ground. And that pyrogenic carbon is going to be stored in the system for millennia now. And that's as opposed to these mega fires that you're seeing right now out west. These are not natural fires. This is when you've got those trees so close together that when one ignites, the entire tree is consumed and the entire forest is consumed. And those burns are so hot that they're sterilizing the soil. So you're losing your seed source. And that's not even talking about houses and cars and washing machines and all that the carbon that's being released. So when we're talking fire, we're talking these light, fast control burns, not these unnatural mega fires. I will take your question if I'm allowed to. I'm done. That's it. All right. So great question. We study a lot of wildlife activity. As soon as that smoke column goes up, the raptors start to circle because they know that all the rodents are going out. The wildlife really knows what to do. They don't have to go very far down to be insulated from these prescribed fires, which are very fast. We do see some mortality, but overall, after a burn, our bobwhite quail populations, our turkey populations, the birds I skipped over, they generally the wildlife populations do very well. Is that it?
Yeah, well,
Okay.
if folks have some more questions for Deborah,